Hi, how are you all? Welcome back to RS Academy. In this video, I would like to explain next concept of fourth chapter, carbon and its compounds of class 10 chemistry. So, homologous series. Get ready, students. So, let us have a clear picture regarding homologous series. Put heading along with me, homologous series. Homo homologous series. Homologous series. So, what is meant by homologous series? Make a note. Homologous series means a group of organic compounds, a group of organic compounds, a group of organic compounds having a group of organic compounds having same structural formula, same structural formula, same functional group, same functional group, and successive successive compounds are successive compounds are differ by CH2 group or 14 grams by mass. 14 grams by mass. The homologous series. A group of organic compounds having same structural formula, same functional group, and successive compounds are differ by CH2 group or 14 grams by mass. These group of organic compounds considered as homologous series. Is it clear to you? Right? Make a note. Homologous series. Alkanes. Alkanes. Alkane general formula CN H2N plus 2. You must have learned this in case of hydrocarbons. I have given clear picture. Please go through that video. So alkanes general formula CnH2n plus 2. So alkane started with first carbon onwards. So the first member of alkane is methane, formula CH4. So methane. Second member will be ethane, C2H6. Ethane. Third member C3H8. Propane. Fourth member C4H10. Butane. Fifth member will be C5H12. Pentane. Listen carefully. In case of alkanes, all members are having same structural formula. Same structural formula in the sense, so only single bonds between carbon carbon. If you take any member from these, you must have seen that only single bonds between carbon and carbon. So same structural formula, same functional groups, alkanes only, same functional groups. These all are having same chemical properties as well. But successive compounds, successive compounds are differ by CH2 group or 14 grams by mass. Let us check. Successive compounds. Here, what is the difference between methane and ethane? Methane and ethane. Let us check. The first member, second member. What is the difference between methane and ethane? CH4. Right. So one carbon. So remains here one carbon. Hydrogen is 4, hydrogen here 6. Right. Difference between these two compounds are CH2. Successive compounds are differ by CH2 group. Successive compounds are differ by CH2 group or 14 grams by mass. So the difference between these two are CH2. Difference between these two are CH2. And then what about these two? The difference between these two are CH2 group. Difference between these two are CH2 group. These two are CH2 group. Not from the difference between first compound and fifth compound. Successive compound. Homologous series means a group of organic compounds having same structural formula, same chemical functional group, same chemical properties as well, but they are successive compounds are differ by CH2 group are 14 grams by mass. So difference between these two are CH2, between these two are CH2, between these two are CH2 as well. Okay, so let us check what is the 14 grams mass. What is the difference 14 grams mass means? Let us check. Right, look into this. Mass of methane, let us take methane CH4 and ethane, let us take C2H6. What is the molecular mass of these compounds? Methane 12, carbon atomic mass 12, hydrogens total 4, 4 into 1, 4, 16 mass. Then what about this one? Carbon 12, 12 into 2, 24 plus, so 6, 30. 30 minus 16, that is 14. 14 grams by mass. That means a group of organic compound having same structural formula, same function group and same chemical properties as well, but successive compounds are differ by CH2 group are 14 grams by mass. So these group of organic compounds are called homologous series. Homologous series are nothing but family of particular organic compounds. So these are the alkane family, alkanes homologous series. So you will get the question in the examination. What is the IUPAC name of first member of homologous series of alkane? What is the IUPAC name of second member of homologous series of alkane? What is the IUPAC name of fourth member of homologous series of alkanes? So please remember that. So learn at least 5 members of in each every homologous series. So the alkane homologous series general formula CnH2n plus 2. First member will be methane, second member will be ethane, third member will be propane, fourth member will be butane, and fifth member will be pentane. So these are homologous series of alkane. Make a note. Alkenes. Alkenes general formula will be CnH2n. CnH2n. So please remember that alkenes homologous series starts with 2 carbons onwards. We required at least 2 carbons to show double bond between carbon and carbon. So alkenes means consist of at least one double bond between any 2 carbon atoms. So alkenes. So alkenes homologous series or alkene family starts from 2 carbon onwards. We required minimum 2 carbons. So that's why there is no methane. Ethene is possible. First member will be ethene. Ethene. Formula C2H4. Second member propene. Formula C3H6. Third member butene. Formula C4H8. Fourth member pentene. Formula C5H10. Fifth member hexene. Formula C6H12. Right? So alkenes general formula CnH2n. First member will be ethene because we require at least 2 carbon atoms to show double bond between carbon and carbon. So that's why alkenes homologous series starts from second 2 carbon onwards. That is ethene onwards. Ethene, propene, butene, pentene, hexene. Right? And successive compounds are differ by CH2 group. Let us check. Ethene, C double bond. This is the structural structure of ethene, and propene will be this is the structure of propene. Let us strike out common elements. Hydrogen, hydrogen, 4 here, hydrogen, 4, carbon, 2, carbon, 2. So what are the remaining? So hydrogen, hydrogen and carbon. So CH2. So successive compounds are differ by CH2 group. Successive compounds are differ by CH2 group. A group of organic compounds having same structural formula, same functional group, and successive compounds are differ by CH2 group or 14 grams by mass is called homologous series. It's a alkenes homologous series. First member will be ethene, second member will be propene, third member will be butene, fourth member will be pentene, fifth member will be hexene. But in case of alkanes, first member methane, not ethane. Okay, please remember that. Next one, if you check the molecular mass difference between these two, you will get 14 because of CH2 groups differ. So difference is CH2 group, that means C carbon mass 12, hydrogens 2 are there 2. So total 14 grams difference. Right. Is it clear to you? Alkenes homologous series. First member will be ethene, second member propane, butene, pentene, hexene. Is it clear to you, my dear? Right? Please make a note of it. Alkenes, alkenes. Carry. Alkyne, alkynes, alkynes. General formula Cn H2n minus 2. So alkyne general formula Cn H2n minus 2. Cn H2n minus 2. Let us check. First member will be as right ethyl. So alkynes homologous series also starts with 2 carbon onwards because of in case of alkynes at least one triple bond must be present between any 2 carbon atoms. To show triple bond we require minimum 2 carbon atoms. Okay, right. First one is ethine, ethine, ethine. Formula C2H2, ethine, C2H2, ethine, C2H2. Second member will be propane, propane, C3H4, C3H4. So just add CH2 to this compound, then you will get next one. So by adding CH2 this one, C3H4. So add CH2 group. Butane, butane. Add CH2 this one. That is C4H6. Next, pentane, C5H8, pentane. Fifth member will be hexane, C6H10. So these are the names and chemical formulas of homologous series of alkynes. Alkynes homologous series is that first member will be so ethane, C2H2, second member propane, third member butane, fourth member pentane, so fifth member will be hexane. So chemical formula C2H2, C3H4. So if you add CH2 group to this one, then you will get next one. Please remember, because of the difference between these two are CH2 group. So to get next number, it could be better to add CH2 group than previous one, then you will get next one. Okay, right. So the homologous series of alkynes. So ethyne, propyne, butane, pentane, hexyne, right? So if you want to find out difference between these two, you can try yourself. C2H2, C2H2. So here one remains, here two remains. So CH2, the difference between successive compounds will be CH2 group or 14 grams by mass. This is a homologous series of alkynes. Please make a note. Up to alkynes, alkanes homologous series, alkenes homologous series, and alkynes homologous series. Now we are going to discuss ketones homologous series, are very important. So make a note, put it in ketones homologous series. Ketones, ketones, ketones. What is the formula of functional group of ketone? C double bond O. C double bond O group must be present between any two carbon atom. That compound must be considered as ketone. C double bond O group. So listen to me. C double bond O group must be present between any two carbon atom. These only considered as ketone. So if C double bond O group present between any two hydrogen atoms, it's not considered as ketone. So ketone means C double bond O group must be present between any two carbon atoms. Is it clear to you, my dears? So ketone means C double bond O group must be present between any two carbon atoms. So then only that organic compound is considered as ketone. Ketone, C double bond O group. Here R and here R. R is nothing but alkyl group. Alkyl group. So general formula for ketones, CnH2nO. Please remember that. General formula ketone CnH2nO. Ketones means C double bond O group must be present between any two carbon atoms. Then only these compounds will be considered as ketones. So ketones general formula CnH2nO. Here n equals number of carbon atoms. You must have know that, right? Let us frame first member of ketone, CH3COCH3. Here I would like to draw the detailed structure as well. CH3COCH3. We can write like this: CH3, C double bond O, CH3, CH3, C double bond O, CH3. Okay, CH3, C double bond O, CH3. So this is called propanone. 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 Propanone also called acetone. Propanone also called acetone. Please remember that. Next one. Add CH2 to this one. CH3, CH2, CO, CH3. CH3, CH2, CO, CH3. It can be written like CH3, CH2, C double bond O, CH3. This is called butanone. 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 Next one. Third member will be pentanone. CH3, CH2. You can add CH2 from this side or this side. That's up to you, not a problem. CH2, C double bond O, CH3. Pentanone. Let me write here pentanone. Especially 2-pentanone, because of keto group is present in second carbon at second carbon, so that's why it is considered as 2-pentanone. 2-pentanone. So in case of ketones, first number start from 3 carbon onwards. So if you want to draw the ketone structure, at least we required 3 carbon atoms. So that's why there is no ethanone, there is no methanone as well. But propanone is existed. Propanone onwards. Propanone also called acetone. Propanone, butanone, pentanone. If you want, you can write hexanone or heptanone. That's up to you. That's not a problem. So general fall of ketones CnH2nO. So this is a structural formula or COR. C double bond O group must be present between any two carbon atom, then only it's considered as ketone. So first member will be propanone, second member will be butanone, third member will be pentanone, third member will be pentanone. Pentanone. So if you want to find out the difference between successive compounds, you can. Right, let us try CH3. Let us try out CH3 and CH3. Here CH3, CH3, CO group and CO group. Only CH2 remains. So according to homologous series definition, so a group of organic compound having same structural formula, same functional group and successive compounds are differ by CH group or 14 grams by mass. So these are homologous series of ketones. Right, next compound aldehyde. 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 Next compound aldehyde. So aldehydes general formula CnH2n same as ketones CnH2nO. CnH2nO. Structural formula C double bond O must be present between any two. So the C double bond O is present at the terminal carbon, end carbon. So then only these considered as aldehydes. For example, so let us assume the carbon chain C double bond O. So these are considered as aldehydes. So C double bond O group present between any two between hydrogen and carbon or between hydrogen and hydrogen. So this one also considered as aldehyde group. So this one also considered as aldehyde or here aldehyde. So aldehyde groups, in case of aldehyde, C double bond group present on the terminal carbon, end carbon. So in case of ketones, C double bond group present between any two carbon atoms. Okay, please remember that. But general formula of aldehydes and ketones are remains unchanged. Same general formula CnH2nO, and in case of aldehyde also CnH2nO. Please remember that. Okay, right. So first member will be HC double bond OH. HCOH. So you can write like this HCHO. This one is called methanol. NaL, methanol, aldehyde, methanol. So this compound generally called as formaldehyde. 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 Right. Second member, add CH2 group this one. CH3 C double bond OH. So this one is ethanol. Ethanol. General common name is acetaldehyde. 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 Third one CH3 CH2 C double bond OH. Propanol. Propanol. So you can write butanol, pentanol, hexanol, that's up to you. So listen to me while writing aldehyde structures. C double bond O group must be present on the terminal carbon, end carbon. So C double bond O group must be present between any two hydrogen atoms or between carbon and hydrogen. So one more point. So C double bond group always present a terminal carbon. Okay, it's clear. In case of ketones, C double bond group present between any two carbon atoms. Right. So formaldehyde, methanol, acetaldehyde, ethanol, and propanol. Propanol is IUPAC name. Ethanol IUPAC name. Methanol IUPAC name. So let us check. Let us check difference between these two compounds. So let us strike out common one. Hydrogen, hydrogen, hydrogen. Here one hydrogen. CO group, CH2 remain CH2. So successive compounds are differ by CH2 group are 14 grams by mass. This is a homologous series of aldehydes. Is it clear to you? Please make a note. Right. So we have done homologous series of aldehydes. Now let us move on to homologous series of acids, carboxylic acids or acids. Acids. Also called carboxylic acid. Carboxylic acid means those acids consist of COOH group. So COOH group. These are called carboxylic acids. COOH group you can write like this: C double bond OH. Right. So COOH group must attach to the hydrogen or carbon, also considered as acids. So if this group gets attached to hydrogen, also considered as acid, and R also considered as acid. If COOH group, carboxylic acid group, if it is gets attached to the hydrogen, also considered as acid. If it is gets attached to the carbon, also considered as acid. Please keep that point in your mind, right? So in case of H, this is called formic acid. Let us look into that. No need to worry about that. So this is a general form of carboxylic acid, COOH. Structure for COOH group must be present in the carbon compound, COOH group. And at the same time, if COOH group gets attached to hydrogen, also considered as acid, or alkyl group also considered as acid. Okay, ma? Right. So general formula will be CnH2nO. CnH2nO2. 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 Okay, right. So let us write first member of carboxylic acid, HCOOH. You can write this structure in detail like this: C double bond OH. So this is called formic acid. Formic acid, IUPAC name will be methanoic acid. Methanoic acid. So formic acid, because so it is present in ant sting. So ant in Latin is called formica. So that's why. So it is considered as formic acid. HCOOH is considered as formic acid, and at the same time it's also considered as or called as methanoic acid. So methanoic acid is IUPAC name, whereas formic acid is common name. Right. Second member, just add CH2 group this hydrogen, CH3COOH. You can write like this: CH3 C double bond OH. This is called acetic acid, present in vinegar. Acetic acid. Acetic acid. IUPAC name will be ethanoic acid. Ethanoic acid. Just add CH2 to get next member. Right, very good. CH3 CH2 COOH. You can write like this: CH3 CH2 C double bond OH. This is called propanoic acid. Propanoic acid. Let us check the difference between these two compounds, successive compounds. Let me strike out common elements. Hydrogen, hydrogen, hydrogen. From here one hydrogen you will get here CH2, C double one group, C double one, oxygen, oxygen. So the difference between these two are CH2 group. So homologous series means a group of organic compound having same structural formula, same functional group, same chemical properties as well, but successive compounds are differ by CH2 group or 14 grams by mass. So here carboxylic acids, in case of carboxylic acid, the difference between first and second member will be CH2. So that's why this is considered as homologous series. So these are few examples for homologous series of carboxylic acids.